why changing climate seems set to disrupt just about everything. From rising sea levels to ocean acidification, the list of negative consequences from climate change is endless. But one area that often goes unmentioned in the climate change discussion is sex. Over the last 2 decades, scientists have found that warmer temperatures are quietly spoiling the mood, making it harder for plants and animals to reproduce. Here are 5 ways that climate change is ruining sex lives. It's a numbers game. While humans and many other animals determine sex genetically, many reptiles and some fish use the incubation temperature of the eggs to set the gender of their offspring. This means that changing global temperatures could alter the ratio of sexes produced, making it harder for these animals to find mates. Eastern three-lined skink females can partially compensate for temperature increases by digging deeper nests and laying earlier in the season. Nevertheless, according to a study published in 2009, their nests still warmed by 1.5 C over 10 years. This shifted the sex ratio towards females. Not every species is as badly affected. Australian water dragon females have been shown to buffer temperature differences of 4 C by nesting in sunnier or shadier locations. When it comes to climate change, behavioral flexibility is often a big advantage. Warmer temperatures are quietly spoiling the mood, making it harder for plants and animals to reproduce in the plant world. Temperature can influence sex ratios in more subtle ways. For example, the tobacco root plant, which lives in alpine meadows in North America, has been producing ever more male plants over the last 40 years. This may be due to reduced water availability, since females require more water to develop. So far, the extra males have actually boosted seed production, but if the trend continues, the lack of females could eventually leave male tobacco roots feeling a little lonely. Meanwhile, the majority of the world's sea turtles use temperature to set the sex of their offspring. Embryos are laid with no gender, says Graham Hayes of Deakin University in Australia. They can develop into males or females. Warmer eggs develop into females, cooler eggs into males. Temperature during the middle third of incubation controls the sex, says Hayes, by switching on and off the genes that trigger development into either a male or a female. The difference between male and female is just a couple of degrees. That means even slight changes in the climate could skew the sex ratio, making males harder to find. Incubation temperatures above 29 C are predicted to produce increasingly female-biased clutches. There is evidence that this shift is already underway. Over the last century, the sex ratios of green turtles, hawksbill turtles and leatherback turtles have become increasingly sex-biased. By 2030, the percentage of male green turtles produced has been predicted to drop to just 2.4%. All else being equal, a warming climate will produce more female sea turtle hatchlings, says Hayes. The difference between male and female is just a couple of degrees, but his research suggests that all things are not equal. High temperatures also increase mortality in sea turtle embryos, so female embryos are less likely to survive. Combine this with the fact that male sea turtles can mate more frequently, and with many females each season, and the impact on reproduction may not be as severe as first predicted. Still, Hayes warns that this is only true up to a point. Temperatures above 35 C would produce such skewed sea turtle clutches and low hatching success that populations would struggle to survive. There are many places where a 3 C temperature rise would lead to extinction of sea turtle populations, says Hayes. One solution for sea turtles and other reptiles with temperature-based sex determination is to breed at different times of year. This is called a phenological shift. Earlier nesting may mean that sea turtles avoid incubation conditions that are too hot, says Hayes. Timing is everything. Phenological shifts are common, because many animals use environmental cues like temperature and rainfall to time key events like migration, flowering and breeding. Climate change is changing the timing and strength of the seasons, and as these cues change, the annual ebb and flow of the natural world is being disrupted. In fact, one of the first pieces of evidence for the effect of climate change on living things was the discovery that plants are flowering earlier and earlier each year. In 2002, a landmark study showed that 385 British plant species were flowering on average 4.5 days earlier than in the 1990s. The same story is playing out across the globe. A 2008 meta-analysis looked at 650 temperate plant species in Europe, Asia and North America, and found that spring flowering had advanced by 1.9 days per decade on average. The biggest concern is that plants and the pollinators might respond differently to climate change, leading to a mismatch that could significantly affect plant reproduction. For instance, in Japan, the flowering of the plant Corydalus ambigua has advanced faster than the emergence of its bumblebee pollinators, resulting in a mismatch that reduces seed production in years with an early spring. Such mismatches could have a major impact on certain crop plants. Happily, a 2011 study found that most plants and pollinators are responding to climate change in a similar way, maintaining their synchrony despite large changes in temperature. Autumnal events, such as fruiting and leaf dropping, have also been delayed. This means that plants are now flowering and growing for longer. That sounds like a good thing, and climate change is predicted to increase yield for some crops in some regions. But overall, the expectation is that climate change will make our crop plants less productive, by speeding the aging process and reducing fertility. It isn't just plants that need to time reproduction carefully. Birds are also changing their annual calendars. Many are now breeding and laying eggs earlier in the year. For some species this may be a good thing, because hatching earlier means the chicks have longer to develop. For pied flycatchers, warmer springs mean larger clutches and more chicks surviving to fledge. For others, climate change may shorten the already narrow window of opportunity to breed. Branax guillemots live in the Arctic Ocean, off the coast of Canada. They time their breeding based on summer ice cover, but ice cover is strongly affected by winter and spring temperatures, and has been retreating since the 1970s. Guillemots in the south of their range now breed earlier, but their chicks grow more slowly and are less likely to survive. In the longer term, warmer temperatures and reduced sea ice may extend the breeding season for birds in the north, but more southerly birds could see their breeding window close early. Changing environmental cues might also influence how animals court members of the opposite sex. More serious problems may be in store for birds that cannot keep up with the changing climate. The relative timing of hatching in relation to the abundance of food is key to successfully raising young. In the Netherlands, peak caterpillar abundance occurred 9 days earlier in 1995 than in 1973, but great tits did not lay their eggs any earlier. This could mean that the chicks get less food than they otherwise could, worsening their chances of survival. Even birds of prey are being affected by mismatches. Eurasian sparrowhawks have found that prey species like common blackbirds and house sparrows are breeding earlier, and the sparrowhawks have only partially kept pace. In the 1970s, the sparrowhawk's prey were most common when chicks were around 2 weeks old, but by 1997 it was happening when they were just 6 days old. At this age, the chicks are too young to make use of this abundance, and may suffer from food shortages later in development. Bending the rules of attraction. Changing environmental cues might also influence how animals court members of the opposite sex. The decorations, displays, dances and songs that animals use to attract a mate are all heavily dependent on the environmental conditions the animal lives in. That is why they became attractive in the first place, says Carlos Botero of Washington University in St. Louis. For example, female birds often find bright colors attractive, and the building blocks that males use to produce these colors are often obtained from their diet, says Botero. When a female sees a brightly colored male, she is indirectly seeing a potential mate that is clearly capable of finding enough food to not just maintain himself but to have extra to spare on looks. Across the animal kingdom, lavish looks and elaborate displays act as honest signals of the quality of a mate, helping females to choose the right parent to give their offspring the best genetic start in life. But environmental changes can break the link between appearance and quality. A study published in January 2017 found that warming spring temperatures had changed the course of evolution for collared flycatchers. Previously, males with the largest white head patches attracted more females, but during the 34-year study a 1.5 degrees Celsius rise in average spring temperatures completely reversed this pattern. Males with large head patches, which previously had the highest survival rate, had the lowest survival rates at warmer temperatures. The head patch no longer meant anything in terms of quality. As a result, males with smaller patches now enjoy their pick of the ladies. Warmer climates seem to have a tendency to make animals less faithful. Climate change seems to be leveling the playing field among gray seals. Between 1996 and 2004, lower rainfall forced females to venture out of their normal foraging areas, giving subordinate males the opportunity to mate. The proportion of males in the colony that bred increased by 61% in wetter years. This in turn has increased the population's genetic diversity, which could help the seals cope with climate change. For other species, changes in the timing of events have left room for exaggerated sexual appearance. Male barn swallows have grown ever longer tail feathers since the 1970s, as a result of arriving early at their breeding grounds. Females have not changed the timing of their migration, so males now have extra time to look their best before the females arrive. This seems like good news for the males, but it may make it harder for females to distinguish between mates of different quality, again altering the course of evolution. These studies offer tantalizing glimpses into how climate change is putting the sexual lives of animals into disarray. However, the long-term consequences of these shifts are difficult to predict and are likely to be highly species-specific. A mate for life. Warmer climates seem to have a tendency to make animals less faithful. In a 2012 study, Botero studied monogamy in 122 species of bird. He found that in places where environments change more frequently and unexpectedly, apparently monogamous females tend to hedge their bets by mating with more than one partner on the side. These extra-pair relationships become increasingly frequent as annual climatic cycles become more variable. Female birds are also more likely to terminate bonds with partners that are no longer yielding the benefits they expected, says Botero. He argues that these divorces and affairs may become more common as the climate becomes less predictable. Increasing infidelity may also be on the cards for mammals like alpine marmots. A 2016 study led by Aurélie Cohas of Claude Bernard University Lyon found that, between 1992 and 2013, the frequency of extrapair litters increased as spring arrived earlier and winter snowfall increased. This effect was largely due to improved survival as alpine temperatures rose. The number of pups, as well as their survival, is highly linked to the climatic conditions they endure during hibernation, says Cohas. Pups that survive the winter will tend to stick around and help the family raise the next litter. In turn, females are more likely to produce extrapair litters when there are more subordinates in their family to help, says Cohas. We could likely expect species living in alpine, snowy and cold habitats to be more unfaithful in the future. Climate change may shorten migration distances, and could actually lead to an increase in monogamy and biparental care in some migratory birds. Why does this happen? Climate influences mating systems in mammals by constraining the resources available, constraining movement, and changing the costs involved for animals to meet sexual partners, says Cohas. Any change in climate that will relax these constraints will likely influence their mating system. In migratory shorebird, there is a link between the distance of migration and whether both parents help care for the young. This biparental care is usually restricted to short-distance migrants, because birds that migrate long distances cannot rely on both parents to make the long journey, so females tend to raise the offspring alone. Climate change may shorten migration distances, and could actually lead to an increase in monogamy and biparental care in some migratory birds. Similarly, among shorebirds called plovers, males have been shown to invest more effort in helping to raise young chicks as the climate warms and becomes more unpredictable. This flexible behavior may help these birds buffer some of the harsher effects of climate change on chick survival. The heatwave slump. Finally, climate change might even impact on our own sex lives. A 2015 working paper by the National Bureau of Economic Research found a correlation between hot temperatures and low birth rates in the USA. A single hot day when temperatures went over 26°C reduced birth rates 9 months later by 0.4%, equating to over 1,100 births. It isn't clear whether this was due to a reduction in the frequency of sex. After all, sometimes it is too hot to do anything, or due to reduced fertility at high temperatures. The authors offer a possible solution to this problem: air conditioning. But air conditioning needs power to run, and if that power comes from burning fossil fuels, we would end up warming the climate even more. A 2016 study in Japan found a correlation between extreme temperatures, whether hot or cold, and increasingly sex-biased miscarriages, producing a female-biased sex ratio in newborns. Since climate change is predicted to increase the frequency of extreme weather events, in theory it could affect human fertility too. Join 800,000 future fans by liking us on Facebook, or follow us on Twitter. If you liked this story, sign up for the weekly BBC.com features newsletter, called If You Only Read 6 Things This Week. A hand-picked selection of stories from BBC Future, Earth, Culture, Capital, and Travel, delivered to your inbox every Friday.